Hello everyone. In this session, we will discuss about folding operations on discrete time signal as well as folding plus shifting operation on a discrete time signal. So basically folding operation is also called as time reversal operation, and folding plus shifting operation is basically operating a shifting operation on a folded signal. So these two topics we are going to cover in this particular session. Okay, so what exactly a folding operation? Time reversal of a signal, or you can say of a discrete time signal, can be achieved by taking mirror image of the signal x of n about y-axis. Time reversal is also known as folding or reflection. Now let us see how this particular time reversal operation occurs. Now as you can see on the screen, the first signal is my original signal. So this x-axis is my time axis and the y-axis is my amplitude axis. So the time axis is n and the amplitude axis is x of n because it is a discrete time signal. Now you can see here that we have some amplitude at different time intervals. At -2 I have an amplitude of 1, at -1 2, at 0 it is 5, at 1 it is 7, at 2 it is 0, and at 3 it is 1. So this is my original signal. My objective is to plot x of -n. That means the time reversal or folded version of the given discrete time signal x of n. So what I'll do, I'll take the mirror image of the signal about this y-axis. So the moment I'll take the mirror image of the signal about y-axis, you can see all the samples which were placed in the right side of the origin have been shifted to the left side, and all the samples which have been placed earlier in the left side of the origin are shifted to the right side, and the sample at origin remains fixed. So as you can see, previously at position 1 I have an amplitude of 7. Now this amplitude has a new place at -1. At 2 we have an amplitude of 0. At -2 we have 0. At 3 it was 1. Now at -3 it is 1. In the same way, previously on the left side of the origin we have two amplitudes at -2 and at -1. So you can see here, previously at -1 the amplitude was 2. Now at 1 position the amplitude is 2. At -2 previously the amplitude was 1, and now at 2 the amplitude is 1. And you can see the sample at origin, which is 5, having a length of 5, remains fixed. So this is how the folding operations or time reversal operation is being done in discrete time signal. The same concept can be applied to the continuous time signals also. Now let us move to the next topic, that is folding plus shifting operation. Now how to perform a folding and shifting operation, folding plus shifting operation. So for that we need to follow some procedure. In the step 1, we will plot the original signal x of n. Step 2, plot x of -n by performing the time reversal or folding operation. That means we have to perform the time reversal and we will plot x of -n. After that we need to plot x of -n minus k. So this particular k is my shift variable, which has been subtracted by the time -n. So this particular k unit is being subtracted with the -n. Now in the previous session we have discussed about the shifting operation, where a particular fixed quantity was subtracted with the time n. In that moment we perform the operation on x of n. Now this time you can see the quantity k is being subtracted from -n. So we will perform the operation on x of -n instead of x of n. So this is the important point which we need to remember in this particular topic. So by shifting x of -n to the left by k unit will produce x of -n minus k. In our earlier discussion of shifting operation, we have seen that x of minus k is a right shift operation by k unit of a given discrete time signal x of n. But here you can see that x of -n minus k is the shifting of x of -n to the left by k unit. Now in the same way, if we need to plot x of -n plus k, we have to shift the folded signal x of minus n to the right by k unit. But the moment we will plot x of n plus k, you might have remembered that we generally shift the signal x of n to the left by k unit. Now let us understand the concept with the help of one example where we will take a discrete time signal x of n and we will plot x of minus n, x of minus n minus k and x of minus n plus k. So this is my original signal. This is my x-axis, which is time axis. This is y-axis. So you can see here the whole signal is between minus 2 and 3. The range of the signal is between minus 2 and 3. At minus 2 the amplitude is 1. At minus 1 it is 2. At 0 it is 5. At 1 it is 7. At 2 it is 0 and at 3 it is 1. So basically the same set of samples we have taken, which we discussed earlier during the folding operation. Now perform the folding operation. Now signal after time reversal will look like this. We discussed already. Now next is folding plus shift right of folded signal. So basically whenever I need to plot x of minus n plus k, in place of k I have 1. So basically we have plotted this particular signal by shifting the signal x of minus n by 1 unit to the right. So you can see here previously at 0 we have an amplitude of 5. Now this particular signal or this particular sample is placed at 1. At 1 previously it was 2, now it has been shifted to 2. At 2 it was 1, now it has been shifted to 3. At minus 1 we had an amplitude of 7, but now it has been shifted to 0 at position 0. And in the same way the sample 1 and 0 has been shifted to minus 2 and minus 1. So this is how we can plot x of minus n plus k, or you can say x of minus n plus 1 for this particular question. Now let us plot x of minus n minus 1. As we discussed already, for x of minus n minus k, the signal x of minus n will shift left by k unit. So we need to plot x of minus n minus 1. So the signal x of minus n will shift left by 1 unit. So you can see here, this is my original signal. The whole signal is between minus 3 and 2. Now the signal has a new range between minus 4 and 1. So basically I can say that whole signal has been shifted to the left by 1 unit. So this is how the folding as well as folding plus shifting operation occurs. So this particular topic is also very important for the semester examination point of view as well as for the gate examination point of view. Thank you.